Hey y'all. So today this is our one of our problems for quest number 7. This is problem 7 on quest 7 as it says, and we're looking at this beast of a situation. We've got a lot of things going on. We got two blocks, an applied force, and an angle. So let's start to break this down. So we have a 4.1 kilogram mass, which is on a frictionless, thank you, inclined surface, and it's connected to this 2.5 kilogram mass. Pulley is massless and frictionless, which is good, and the string is also massless and doesn't stretch. So that's all of our little boxes we need to check to make sure that this is kind of an easy problem and not as much of the more advanced stuff that we have to really think about. We know the 2.5 kilogram mass is acted upon by an upward force of 3.9 newtons and has a downward acceleration of 6.1 meters per second squared. The acceleration of gravity is 9.8 meters per second. We're asked to find the tension in the connecting string. So I can do it two ways. The first way I can do it is I can look at the hanging mass, which is the easier one and the only one you can do. And the second way to do it is to look at this one. We can't do this one quite yet because we're not given this angle. That's question 8 down here, is to find that angle. So we're not given that angle yet, so we don't know enough about this situation yet to start to solve. So we have to use this one, this hanging mass. So as always, I'm going to start with a free body diagram. I want a darker blue. There we go. I'm going to start with a free body diagram. So here's our box. No, I want blue. Here's our box. We have tension, which points up. We also have our applied force here, which I'm going to call F. And we have the weight force, or the force of gravity, which points down. So that is our three forces. That's our free body diagram for that hanging block. Okay, so now next thing we can do is we can write Newton's second law. We know it has a downward acceleration. So just to make things easier, we're going to call that our positive direction. Since it's accelerating downward, we're just going to call that our positive direction. That'll make it easier. So from here, we can start to use Newton's second law. That means the sum of the forces equals the mass of the object times the acceleration of the object. We know both of these things, which is good. So then we say, okay, what is the sum of all of our forces? So since down is positive, we're going to have a positive gravitational force, positive Fg, and then these two forces up here are going to be negative. So minus the tension, minus this applied force, and that is equal to the mass of the object times the acceleration. Now we can do some rearranging of this expression. We can do some algebra here to get that the tension is equal to the force of gravity minus this applied force minus the mass times the acceleration. So move this over to that side, move this over to this side, and that's how you get that. That the tension is equal to the force of gravity minus this applied force minus the mass times the acceleration. So let me start to plug in numbers. Here I get the tension is equal to the force of gravity is the same as mg, the mass of the object times the acceleration due to gravity. So that's going to be 2.5 kilograms multiplied by 9.8 meters per second squared minus our applied force of 3.9 newtons minus, and sorry, it's not all on one line, just don't have room, the mass. I'm going to actually move it over here further. Minus the mass, which is once again 2.5 kilograms times the acceleration, which is 6.1 meters per second squared. Okay, so after having done all of that, I can plug this into my calculator, hand in a calculator. And I like to do it all in one step, just so I know that I didn't accidentally mistype something. But you can do it in multiple steps if you would like. And I get that the tension is 5.3, that's a really bad 3, 5.35 newtons. So that is your final answer. Remember, for this problem, that you're going to have different numbers. So make sure you're using your particular numbers for this problem and not what I've used. The algebra and the process is the same, but the numbers are different. So hopefully that helps. Good luck, y'all.